All right, this is the 1.7 lesson for my grade 10 MIAP students. A composite object is two or more 3D objects attached along plane faces. Here's what we mean by that. I'm actually going to go grab one of these. There. This is basically our first example, right? Yeah. Except for it's not a cube on the bottom, but you get the idea. So right now I'm holding up a square pyramid on top of a cube. So, my surface area for this thing is going to be the surfaces of this triangular prism, the surfaces of this square prism, but notice the two shaded faces, those aren't surface anymore, right? So, the surface area of this object is a square plus 4 triangles. The surface area of this object is 2 squares and 4 rectangles. But when I glue them together like this, I lose one of these squares and I lose that square. Think about why that is. Surface area means the outside of the object, the part that touches the air. If I put it through a spray painter, it's the part that would get spray painted. So, the surface area here, I still kind of do it as two little calculations. The surface area in total would be, okay, it would be one of the one square it sits on, 10 squared. So that will be this part, right there. Okay, or here, that part. Plus, let's do the rectangles next. So there's 2 rectangles that are 11 by, actually there's 4 rectangles that are 11 by 10. All the rectangles here, let me get a different color. There we go. All the rectangles here, 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 all 4 of them are all the same. They're all 10 by 11. So I have 4 times 10 by 11. So that takes care of the green parts here. So that's the green, the green, the green. Okay. Then I have 4 triangles. So I have 4 times base times height, which is 10 times, they give me a height of 9, divided by 2. And that takes care of these triangles. And now I'm ready to calculate. Okay, let's make this a little simpler. Let's see how much of it we can do without touching our calculator. 10 squared is 100. 10 times 4, or how about 11 times 4 is 44 times 10 is 440. That's nice. And then how about this 2 goes into 4 twice? So I basically have 18 times 10, which is 180. And there we go. Add all that together, and I get a composite surface area of 720. Let me make that better. 720. And what unit are we in? We're in square centimeters, because this is an area. Any questions on how I did that? There's all of my thinking on one spot. Notice I really want to see this work here that I'm highlighting, right? I really want to see your logic as to how you put your formula together. I'm certainly not going to, on the formula sheet, give you a formula for this particular shape, because it's made out of 2 shapes that you already know. You just have to remember, oh yeah, I have to not count the bottom of this pyramid and the top of this prism, because they're not surface anymore. Does that make sense? All right. Interestingly enough, volume's much easier. Because do I lose any volume by gluing these together? No. I lose area. I lose this bottom area and this top area by gluing them together. But do I lose any of the space inside? No. So volume's actually a lot easier. So the B part, the volume, is just add the pyramid to the rectangular prism. Easy peasy lemon squeezy. The area of the base here, okay, what is the area of the base? The area of the base for the pyramid is 10 squared. And how tall is it? Oh, wait a minute. How tall is it? Oh, we don't know how tall this pyramid is, do we? Do we? No, we don't. So we're going to have to go off and find that height. So let's go find, oops, not you. You. We need to find that height, so let's find it. The pyramid has, let me draw it again here, right? A height right to the middle there that I need to find. And if I go and I make a triangle from here to here to here, or, well, will that help me? Let's see. Yeah, okay, they told me that this is 9. And if it was 10 all the way across, this has to be a 5. So the h here, squared plus 5 squared would equal 9 squared. So h squared would equal 9 squared minus 5 squared. So the h squared would equal 81 minus 25, which is 56. So h is the square root of 56. So that height goes there, the square root of 56. Then the rest is easy. The bottom part, length times width times height, 10 times 10 times 11, length, width, height, 10, 10, 11. And I think we're done. Just got to punch buttons now. Let's move that over and punch some buttons. I like doing 1/3 as 1 divided by 3. You can always do this divided by 3, like 10 squared times square root of 56, and then divide by 3. I'll do it that way. 56 square rooted times 10 divided by 3 plus, I don't think I need a calculator for this part, 11 times 100, 11 with 2 zeros on it, equals, and I get 1,124.94. Okay, sounds about right. I don't have an answer key. 1,124 point, where does it round to? 2 decimal places, so 44. So 12494. 1, 2, 1. Whoop, I missed a 1. 124.94. And what unit are we in? I've forgotten what we were measuring in. We were in centimeters. So this is centimeters cubed. Okay, so let's see. 25, 6, yep. Okay, let me just double check the button punch. Make sure I did that right. 1/3 times 100 times 56 square rooted plus 100 times 11 is. I punched buttons wrong. That felt like it was too small. So that's why I double punched. So look at that. See, always a good idea on a test to double punch your numbers. So let's see. So 1349.44, that's better. There we go. Okay. Make sure for the next one you guys punch along with me to catch me again if I punch buttons wrong with my clumsy fingers. All right. Let's put together now these two. Cylinder and a cone. All right, so what's going to happen this time? Well, remember that the formula for a cone surface area is pi r squared plus pi r s. And they give you the s, that's the 5. And remember that the surface area for the That's the cone. And the surface area for the cylinder is 2 pi r squared plus 2 pi r h. But what am I going to lose in area when I glue these two things together? I'm going to lose 2 circles. So you know what I could do? There. My formula is ready to go. Total surface area is pi r squared plus 2 pi s. Oh, wait a minute, is it 2 pi s? No, it's pi rs, isn't it? Yeah, that's a mistake. Can you fix that? My eraser's not working. Ah! There we go. Plus pi rs. That's better. So, my total surface area is this pi r squared plus pi rs plus 2 pi rh. And again, why did I lose 2 pi r squared? Well, I lose 2 circles. The circle on the bottom here and the circle on the top here, they meet in this little region here, and that's not part of the surface. If I dunked this in a can of paint, if it was glued together properly, right, these two would still be a bright orange when they're done because they weren't part of the surface, right? So, I think I'm ready to put in some numbers. Let's see what we get. Surface area is pi times 3 squared plus pi times 3 times 5 plus 2 times pi times 3 times 6. Here's one where I'm going to not touch my calculator for a minute. This is 9 pi, 15 pi, and I got to think about this one. 6 times 6, 36 pi. 9 plus 15 is 24. 24 plus 36. This is 60 times pi. And if this was a course where I wasn't giving you a calculator, you'd be done there and say it's 60 pi centimeters squared. But this one does say use your calculator and round to 2 decimals. So now I punch buttons. This is a lot. Notice I punched buttons wrong last time because there was just too many buttons. I am not going to goof up 60 times pi. I just doomed myself to punch the wrong button, didn't I? But I'm going to try. 60 times pi. And there we go. 188.495, so 0.50. 188.50 centimeters squared. And there we go. Just like on the last example, guys, the volume doesn't lose any space. When I stick this cone on top of this cylinder, I don't lose any of the space inside either object. I lose this outside circle and that outside circle of 2D space, but my 3D space is all still here. So volume is much easier than composite surface area. So the volume is just pi r squared h plus 1/3 pi r squared h. And by the way, would you like to simplify that before you punch buttons? I've just demonstrated how button punching is the worst part of this. I suck at it. What do you notice? If you have 1 of something plus 1/3 of something, what do you have? Yeah? What's that? Oh, unfortunately, good. That was it. You caught it. Can I add these together? No. These two heights are different. Some people, when they're doing this, would even say, this is the height of the cone. They'll put a little CO for cone, and they'll put a little CY for cylinder. Because no, I can't add those together and say it's 4/3 pi r squared h. Thanks for ruining my fun. Oh, do I have them backwards? Oh yeah, I do. Whoops, my bad. This is the cylinder. This is the cone. Can you fix that? Thank you. No, you can't add them together. They look like they're like terms, but they're not. Their H's are different. Why don't we just use two different letters? Why use the same H if it means two different numbers? Well, what else do you want to call it? It's height. I like putting subscripts on it. That's how I tell the difference. All right, let's put in numbers. Pi, what was my original R? My R was 3. My H was, for the cylinder, was 6. 1/3 pi 3 squared, and my height for the cone was 4. No, what was my height for the cone? Oh, they didn't give me a height for the cone. So let's see. The cone has a 5 here. The radius here is 3. Oh, this one you can do without calculating. 3 blank 5 in a Pythagorean triangle. Yeah, 3, 4, 5. If you need to see the work, 3 squared plus h squared equals 5 squared. H squared is equal to 25 minus 9. H squared equals 16. H equals 4. So this is times 4. Okay? And I'm ready to punch buttons now. This time, okay, you better punch with me because there's a lot of buttons. I'm bound to goof this up. Alright, let's see. Pi times 9, right, 3 squared, times 6. Problem is I can't see what I'm doing. Let me start over. Can't see what I'm doing. Pi times 9 times 6 plus 1 divided by 3 times pi times 9 times 4. Is that what you get?
Yes, I do get that.
I see one person said yes, 2 other people are shaking their heads yes. Okay, we'll say we got it. 207, careful with the rounding. The thing after the 4 is a 5, so it's 0.35. And this is now centimeters cubed. All right, one more. What if we stuck a hemisphere on top of a cylinder?
Actually, it's not.
This looks more like a grain silo. So surface area is, okay, what is my surface area here? Well, I have a circle down here. Okay, right? There's pi r squared. There is no circle between these two objects here, between the hemisphere and the cylinder, because it's not part of the outside surface. So it's one circle. Then there's the outside part, which is 2 pi RH. And then there's the dome part. And the dome part is 2 pi r squared. This time, are the 2 radii the same here and here? They better be, or else they don't fit together. So this time I can add this and this like they're like terms. So this is 3 pi r squared plus 2 pi RH. I had somebody ask me once, why can't I add these 2 together and make it even simpler? Well, this one is an r squared and that's only an r, and this one doesn't have an h, so they're not like terms. Does everybody get how I got the 3? I added these 2 terms together. All right, I'm ready for numbers. 3 pi 18 squared plus 2 pi 18, and the height of this thing is 32. I don't think I can do much of this one in my head, so this is lots of button punching for this one. All right, ready? Let's erase everything and start over. 3 times pi times 18 squared. That's square rooted. Back up. Oh, now I gotta start over. 3 times pi, sorry about that, times 18 squared plus 2 times pi times 18 times 32. I am getting 6,672.74. Is that what anybody else got? Okay, we have confirmation. I have successfully punched the buttons on the second try. Okay, so I had to consider the fact that I had to count how much area there was, and in here we lost 2 circles. Once again, for volume, you don't lose anything. So the volume is the volume of the hemisphere, which is the formula we looked at a little while ago, plus the volume of the cylinder. So plugging in the numbers, that's 2/3 pi times 18 cubed plus pi times 18 squared times 32. All right, once again, let's punch buttons. Erase, erase, erase. 2 divided by 3. You can use your fraction button if you have one. Times pi. Pi, that didn't work. Times 18 to the power of 3. Some of you have your button that actually is cubed. I don't have one, so I got to say power of 3. Plus pi times 18 squared times 32 equals. Do I have confirmation that that's the right number? I'll give you a sec to try it.
We all get answers.
We have 3 people, we have 3 different answers. That's not good news. Somebody else try it. It's got to be you. Okay, we've got confirmation. This is it. 44,786.54 cubic centimeters. Because it's a hemisphere, not a sphere, right? Okay. The question that the microphone maybe didn't pick up is, why is this 2/3? Remember that for a sphere, that the volume is 4/3 pi r cubed. For a hemisphere, that would be half of that.
Now I know.
2 goes into 4 twice. So the volume for a hemisphere is 2/3 pi r cubed. Get it? Half of the other one. Okay? All right, any other questions about that? That's a good question. All right, I'll stop the video here.